Hi everybody, my name is Christian and today I'll walk you through a practical example of how supervised machine learning is applied in the AC industry, specifically for detecting safety helmet compliance on construction sites. So the process, as you can see, is divided into four steps. So first one is labeling, then training, after that testing, and the last step is verification. So the process starts with labeling, which is the foundation of supervised learning. In this step, human annotators manually go through a collection of construction site photos and draw bounding boxes around workers, identifying whether or not they are wearing safety helmets. Each annotation is paired with a label like helmet or no helmet. And as shown on the left side of the slide, red boxes indicate non-compliance, so no helmet, while blue boxes show compliance, or the helmet is worn. This labeled dataset becomes the ground truth that the model will use to learn what is correct behavior. And why is this important? This is important because if the labeling is poor, the model will learn the wrong things. Accurate annotations are critical to building a reliable AI system. So once we have labeled enough data, we move into the training phase. This is where we feed the labeled photos into a machine learning model. Typically, neural network, which begins to learn how helmets look. So neural network recognizes their shape, color patterns, and their typical location on a person's body. So in the center of the slide or a bit on the left, you'll see a neural network diagram. So we start from the labeled photos and we end up with a neural network model. So each input node receives an image which is processed through multiple layers of neurons. The model learns features such as edge patterns, color clusters, and object outlines, and uses them to predict the presence or absence of a helmet. Over many iterations, the model adjusts its internal weights to better match the correct labels. This is the core of the learning process. And and after initial training, we enter the testing phase. Now we show the model new images it hasn't seen before, but ones that still have labels. This allows us to evaluate how well it generalizes beyond the training set. We'll look at metrics like accuracy, precision and recall, false positives and false negatives. So if performance isn't satisfactory, we may go back and retrain the model, tweaking the architecture, adjusting learning rates, or even improving the dataset itself. This back and forth loop between training and testing is typical in any supervised learning workflow. And once we have got a well-performing model, we move to verification. This is where we put the model into a simulated production test using completely new unlabeled images. For example, live feeds or recent site photos not part of the original dataset. Uh, so you can see on the left side of the slide, the model identifies workers and classifies them in real time. Blue boxes for correct PP usage and red boxes for violations. These steps ensures the model is reliable in real-world settings, where lighting, camera angles, and worker positions vary. If it performs well, the model is considered ready for deployment, perhaps integrated into smart safety system or inspection tool. This is classic supervised machine learning pipeline. So first label the data, second train and test the model iteratively, and third and final verify it on unseen data. And while this example focuses on helmet detection, the same approach can be adapted, for example, for detecting harnesses or gloves, for identifying unsafe behaviors, for classifying construction activities, so for example welding, pouring concrete, counting workers, or monitoring site productivity. Supervised learning gives us a scalable and data-driven way to automate compliance and safety across the construction sector. Thank you for joining me on this short lecture, and I hope you learned something new.